Hi folks, and welcome back to Physics with Captain Rod. The purpose of this video is to uh, introduce you to Newton's first law of motion. There are three laws of motion that are used to describe the motion of a particle or system of particles, and we're just going to focus on the first one at this point. And what we're looking at here, we're going to focus on this picture on the left. Here's an automobile. Now imagine this is a nice level ground, and the automobile is in neutral, so it's free to roll. And for just a moment, pretend this man is not here in this picture, right? If we were to draw a velocity graph of the car before this person does anything, presumably the car's not moving, so its velocity would be zero. And it would basically, if the car's just sitting there, this velocity curve would be pretty boring. It would sit at zero out to some time here. Now imagine that this person walks up and starts pushing on the car. Now in physics, when we say pushing on the car, we call that a force. So when this person pushes, they're applying what we would call a force in the following direction. And what's going to happen now is the car probably would start to roll. And on this velocity graph now, the car is going to start moving a little bit. So now it's going to have a velocity, and if this person continues to push, the velocity should get a little bigger, a little bigger, a little bigger. Then imagine, the car's rolling and the person stops pushing. Well, the car would then tend to roll on at pretty much constant velocity. Now, it may slow down a little bit due to friction or, some sort of drag, between the tires and the ground. There'd be a little bit of a frictional force between the tires and the ground and within the bearings and stuff like that. But for the most part, anybody watching this video, what you need to realize is if the car's just sitting here, and the man is not pushing, the velocity would be zero and not changing. When the man pushes on the car, now the car will start to roll and its velocity will change. Right? So now the graphs may be looking something like this. An important thing to realize is that if he continues to push on the car, the velocity will get a little bit more, a little bit more, a little bit more. If he stops pushing on the car will just roll on at pretty much constant velocity. So this graph kind of represents what the velocity of the car would look like if this person walked up, applied a force, got the car rolling, and then let off the force. Zero velocity, increasing velocity, constant velocity. So this is an example of Newton's first law of motion. When you read it in the book, it'll say something like this. An object in motion will tend to stay in motion. An object at rest will tend to stay at rest until it is acted upon by some sort of external force. I think that's kind of a long-winded way to express it. I like to say it like this. If you want to change the velocity of an object, you have to apply a force. Force is the quantity that changes velocity. That's my short version of Newton's first law. Your velocity will stay constant until you have a net force acting on the system. The word net is very important because this car here, there's lots of different forces acting on it. There's the gravitational force, there's what are called the normal forces between the tire and the road. There's many forces acting on this car. But the net force is zero until this person walks up and applies some sort of external force. And that external force is what's changing the velocity of the car. So, again, Newton's first law is really about this region in this graph. The velocity was zero and not changing because the net force was zero. In this region right here, the velocity is increasing because there is a net force applied to the car by this man. And again, if the car is just rolling at constant velocity, then the net force on it basically would be zero again. Let's take a look at this pool ball. Same type of idea. Right? Before the stick hits the ball, the net force on this pool ball is zero. There are forces there. There's a gravitational force acting down. If we actually drew a vector for it, it would look like this. The ball is being supported by the ground. That's an example of what we call a normal force. In the picture, it would go up. But there's nothing else in contact with that ball. So at this point in this picture, these two forces vectorially add to zero. There's no net force, and therefore the velocity of that pool ball will stay constant. On this graph, I could graph it. It would be staying at zero, not just constant, but at zero. As soon as the pool stick hits the ball, this velocity will very quickly change to some value. Now what that value is not important for the discussion, but the important thing is there's going to be a very short time frame, a very short window where the stick is in contact with the ball. At that point, it is applying a force on the ball in this direction. It's going to be a very short time frame in that example. In physics, we would call that a delta t, a small time frame, where the ball goes from zero velocity to some new velocity, whatever this is. So if I did the velocity graph for this pool ball, it might look something like this. Before the stick was in contact, the velocity is zero and not changing. After the stick leaves the contact, or after there's no contact, the velocity is typically, pretty much constant. It's what's happening in this region. While the stick is actually in contact with the ball, we're now going to have a net force, and that force is going to change very quickly in this example, change the velocity of the ball. So again, Newton's first law of motion is, it's stated a lot of different ways. My shorthand version is this. In order for a velocity to change, in order to have a change in velocity, you have to have a net force. Net force is what changes the velocity of an object or some sort of system. So that's pretty well Newton's first law in a nutshell. Your velocity will stay constant until you have a net force. Right? That's another way to state it. So anyway, I hope this video helped describe Newton's first law of motion. Have a great day.